Hi everyone, section 0.9 on simplifying algebraic expressions. This is a huge topic. So let's hone our basic tools. A key tool being canceling common factors in a fraction. Very important. Now, some instructors object to the term canceling because students get what my colleague Tony Parsons calls cancel happy. Students often tend to match things up and try to erase them. Be very careful about that. And in fact, a better term than canceling might be dividing or dividing out. When you're canceling, you're really dividing. So what are some principles for canceling or dividing with fractions? As we simplify a fraction, we can cancel a factor of the entire numerator with a factor of the entire denominator, provided that they're non-zero and they're equivalent, like an x and an x. In other words, we can divide the entire numerator and the entire denominator by equivalent non-zero factors. All right. For example, consider this rational expression, x over x squared times the quantity x plus 4. You can see that x is a factor of the numerator, and x is also a factor of the denominator. In particular, it's a factor of x squared. So we can divide the top by x. X divided by x is 1. You have to put the 1 up there. It might even be safe to put parentheses. And then x squared divided by x is x. A lot of students are tempted to just scratch out the exponent. That's micromanaging. That's almost messy in a way. So don't do that. Strike out the entire x squared and put an x below. Again, parentheses are nice to be safe, to indicate that that's a factor of the bottom. And then we can simplify this expression as 1. You need that 1 on top. Don't engage in wishful thinking, folks. You still have a fraction, okay? You have a fraction with a 1 on top now, over, we now have x times the quantity x plus 4. And these two expressions are perfectly equivalent. And notice that both x equals 0 and x equals -4 are illegal, clearly, in both expressions. So we've basically canceled a pair of x factors. We canceled an x factor on top with an x factor on the bottom. We're assuming they're non-zero, and they are equivalent. So this does work out. You can divide out the x factor on top and an x factor on the bottom. Okay, now what if we have something like this? X over x squared plus 4. X over x squared plus 4. Now, a lot of students would do the following. Oh, x goes into x once, x goes into x squared, x times, I get 1 over x plus 4. No, you don't. No, you don't. No, you don't. Why not? Why is that illegal? The problem is that x is not a factor of the entire denominator as it stands. So if you have x over x squared plus 4, we cannot cancel a pair of x factors in the classical sense because x is not a factor of the denominator. Now, if we just had x over x squared, then yeah, x is a factor of the top, x is a factor of the bottom, then you could do a cancellation or division with x's. But the plus 4 down here ruins things. Generally speaking, you want to avoid that kind of top-bottom canceling or division if you have more than one term in the top or the bottom. See, over here, with these guys here, we had factored forms. We had one term, x on top over here, and we had one ugly term on the bottom. It had two factors to it, but we had one term on the bottom. There were no primary plus or minus signs. This one in here doesn't count. Over here, we have two terms, two bona fide terms in the bottom, so I do not advise top-bottom canceling or dividing as it stands. All right. Another thing you have to be aware of, hidden restrictions could also arise. For example, if we want to simplify x squared over x times the quantity x plus 4, well, x is a factor of the top, the numerator. X is a factor of the bottom, the denominator. So here, canceling or division would be appropriate. X squared divided by x is x alone. I'm putting parentheses just to be safe. Over here, when we divide the bottom by x, well, x divided by x here is 1. It's good to indicate the 1 down here. Right? And the x plus 4 still survives. So you end up with x over x plus 4. And that's basically correct, but bear in mind, there is a hidden restriction. I'll put this in red. There is a hidden restriction that you should be aware of when you're dealing with domain issues. Because bear in mind, in the original expression, 0 is an illegal value for x. If you try to plug in 0 for x, you're going to end up with a 0 denominator, which indicates division by 0, and that is illegal. That's not allowed. So 0 is an illegal value for x at the very beginning, and 0 will always be an illegal value for x as we simplify the expression. Now, when we perform a cancellation step where we completely cancel x factors in the bottom, then we hide that restriction. So in this final expression, x over x plus 4, it's no longer evident that x cannot be 0. So this restriction, x cannot be 0, is hidden. And we really need to write hidden restrictions. Such restrictions must be written out separately, all right? Again, when canceling, if a factor, like an x factor, is completely eliminated from the denominator, check to see if any restrictions have been hidden. In this case here, the restriction that x cannot be 0, that's hidden when you completely cancel the x factors in the bottom. So you should indicate that restriction. It's usually acceptable to wait until the very end. You don't have to indicate the restriction as soon as you do the cancellation, but you should indicate it by the end. So now, what I've put in the oval here is now perfectly equivalent to what's in the squish circle here. These are now perfectly equivalent. It's evident that x cannot be negative 4. That should be evident from both expressions. If you want to write that, that's fine. But the hidden restriction is more imperative to write. All right, next up, fancier ways of dividing or sort of canceling.